continue with this lesson. We discuss friction loss in supply system, and it can be applied to compressed air or water supply system. That both system that we discussed in today's lesson. So for pressure drop in a pipe for the compressed air, that is a function of the airflow, the pipe size, so depends on the diameter of the pipe, initial pressure at the receiver, and the pipe length. It will be determine the loss. The length is the more length, the more loss you will have for the pressure. To determine the drop for 1,000 feet of the pipe at the initial pressure of 100 pound per square inch psi gauge, then we use table 9.4 that I will show in a minute, and then we need to have a correction factor because for the table 9.4 apply for 1,000 psi's, but in the real life may need more or less than 100 psi, then we have correction factors, and that table 9.4 apply for both pipe and hose in the compressed air system. And then for the pipe fittings, we use equivalent length. So if you have different pipe fitting here, elbow or chain in the diameter, bigger diameter to a smaller diameter, just connection with the same diameter, all of that fittings, it need to be, as you can see, the water or air go from smaller to bigger, have a friction loss in there, and that in air we call it pressure drop, and that need to be adjusted, and that's same as something we do in the fluid mechanics. Then we need to do the equivalent length. Okay, let go the water go through here and do the fittings and get lost, pressure loss here, or the water head loss in there. It equivalently, this one loss how many feet equivalent to the pipe, and that is the way we do. And how to do that, it use figure 9.4 available in the textbook, in the slide for today's lesson, and also in your reference. And your job is how to can be able to get the input information and use that figure 9.4 to determine the equivalent length for different fittings. And of course, then it go to the hose before they connect to different construction tools and equipment that use compressed air. Then the same process used in pipe, which is if they have fittings, do the same. If they have a loss throughout the pipe, then we use table 9.6, similar to 9.4, but 9.6, and it will be dropped per 150 feet hose and at the pressure of 100 psi gauge. So it's same at here, but that 9.4 for 1,000 feet of the pipe, for the whole 50 feet. If something not 100 psi for the hose, do go to table 9.5 to adjust for correction due to the initial pressure is not at 100 psi. So that's the process to do. And that let's go to the a few table, and then the next video you will see the how to solve with that, apply this friction loss in problem 2. So let's go to a few explanation for the table. So the first table, we determine the pressure drop caused by the pipe friction. So as you can see, the air go through this pipe, the friction between the air and the pipe, then it determined by 1,000 feet of the pipe and adds the pressure of 1,000 psi gauge. So this one, and it depends on two parameters. First, what is the nominal diameter of the pipe? What is the nominal diameters? And then what is the flow the air go through? And that the two you have it in there. So as you can see, the more air you go, it more condensed, right? And then with that, you see the pressure drop, it will be increasing with the flow increasing. With the same flow, but if the pipe have a bigger diameter, then the loss in the pressure drop will be reducing. So that the two factor that you have it in the pressure drop. This concept you learn in fluid mechanics. So that to see the pressure drop when the air go through the pipe. And the if it's not pressure at initial start of the pipe, not 100 psi gauge, and that table apply for both pipe and hose, then we need to do adjustment. So if it's lower, then the correction factor is more than 1. If it's greater than 100, then the correction factor is less than 1, as you can see there. And then for the fitting, different fitting, we need to determine the friction loss or pressure drop when it go to the fitting by determining with that equivalent what is the length of the pipe, so that we got equivalent length. And with that one, we first, there is 3 major vertical lines that you need to consider. The first, we need to know what type of fitting we are talking about. Lobe valve, open, angle valve, standard elbow, standard T, all of that. And then go to the arrow. For example, here, if we talk about the standard T, then the arrow here go there. So this is the point, the first line what we know. So that what fitting is that? Have to find out that point. And then what is the diameter, nominal diameter of the pipe? That go to the second point. For example, let me make a nominal. So the if you have a standard T, so we have that here, and then we want to know this is 1 inch of the diameter, nominal diameter. Then you draw the line between those 2 points, straight line. It's not straight, it have to be straight line in there, okay? And the intersection of this one, you will get the equivalent length. For example, here is about 5 or 6, and need to be a straight line that you have. So that is basically the equivalent length. Get what type of fitting we are talking, what type of fitting, what is the nominal diameter, draw a straight line, whatever intersect in the middle vertical line, read that is the equivalent length of that fittings. So same process apply for all others. So that how to read the equivalent length given the time of the fittings and the nominal diameter of that fitting. And then for the hose, instead of adjustment for 1000 feet like in the pipe, it's 100 feet. And then it of course depends on the flow, and it depends on the nominal size of the hose. And that same process we did for the pipe, but you see for 100 feet. If it's not 100 psi at the initial pressure, then we have to go back to this table to adjust for friction loss given the initial pressure are not at that 100 psi gauge. So with that, with that information, the next video I show you how to apply this process in problem 2, and it's very important that you can be able to determine the equivalent length for each fittings, that be able to use finger knife and adjustment, and find out the pressure drop for pipe and hose.